Okay, my name is Jonathan Dunbar. Our content area today is going to be scaffold erector. Today's November 26, 2018, and our lesson title for today is Compression Cantilever Clamp Orientation. So this is a small version of a cantilever, compression. Something's being held up on one side and pushed down. It's a compressive force. So I got the correct way for our 4 load-bearing clamps to be installed, and I have the incorrect way for our load-bearing clamps to be installed. And we'll go into further discussion on that as we go. So everybody has a bolt clamp in front of them on their desk. If you go ahead and pick it up, and we'll discuss the parts of it and some important things to note. So right angle clamp, any load bearing clamp is going to be a right angle. All these are right angle clamps. If it was a swivel clamp, it would swivel. But they have 2 halves. Okay, there's a half and a half on all clamps. This one's rigid in the middle, so it's a 90 clamp. So we'll just talk about the half. It's the exact same on the other side, as you can tell. But so you got the cup and the hinge, which is where the weight needs to be placed. So you have the cup, the hinge, you have the bolt and the nut. Some things that may cause a clamp to fail is somebody may tighten this down too tight. It's supposed to be 40 to 45 foot-pounds of torque. You may tighten it down too tight, and then you know, after so many times, bam, it breaks, and then the cup falls open. And the important reason to have the clamp orientated properly is if that happens and there's the tube is in here and it breaks, the bolt breaks, the cup will catch it. Okay, the cup wants to catch the weight. If it were the other way around, obviously you could see that if the bolt broke, whatever was resting in there would just fall out, and then you'd have an issue on your hands. Major injuries, possibly even death. Hopefully not. Another thing that might happen is people will back these all the way off, and if you look closely, you can see there's notches in there. They back them off too far, and then when they go to tighten them back down, they cross thread, ends up damaging the threads and potentially causing the bolt to fail. So those are your main parts of a clamp. You got your cup, hinge, bolt, nut, and how it's attached to the body on both sides. This one happens to be rivets. Okay, I'll go ahead and set these down. You guys have a picture of a full-size cantilever on your desk. Take a look at that. This is just a small version of that. Okay, so here's obviously the work platform where the workers would be working from. So the weight would be forcing down this way, top down, right? So these are all orientated properly. Let's see what would happen if this one were to fail. And everything's kind of loose, don't worry about that, it's for demonstration purposes. So if this one were to fail, and the weight would come down and the cup would catch it. Everybody see that? Okay. Back up. Just get it on there. And then we'll look at what happens on the other side. The other side's the opposite way. So not only is the tube on top of this one's on bottom, which is incorrect. The cup is on top right here. The cup is on bottom right here, which is incorrect. So let's say this one were to fail. Man, total platform support failure. Put that back in there. So you can see, and then let's go up to the top one. The cup is on the top, which is incorrect. Cup should be on the bottom. So let's see what happens if this one were to fail. This would be held rigidly up, and so this would just fall down. No cup catching it. Obviously there'd be, a couple 100 pounds up here, so it'd move with a little bit more force. If we look at this one, the cup's on the bottom, the tube is on the bottom. I forgot to mention the tube's on top on this side, which is incorrect. It should be on bottom, and the cup should be on bottom, like you see here. And then say this bolt were to fail, it's going to fall and land into the cup. So the cup is catching the weight. Okay, so there's that one. Let's look at this one here. You can see the weight is being pushed downwards. So let's see what happens with this one. It comes loose. Yeah. Weight comes down, cup catches it. Clamp is incorrectly installed. Cup's on top rather than on bottom, right? Weight's being pushed down. I'm sure you get the idea. Total scaffold platform failure. Can't have that. Extremely important to have the clamps orientated properly. So you saw that one caught it. This one. This is the fourth and final clamp. You can see the cup's on the inside. Force is being pushed down. This is holding it up, so it's, if anything's going to happen, it's going to come out this way. Then, bang, comes out. Scaffold platform support failure. Injuries, death, not good. Let's look at this one. Also, it's on top. Should be on bottom. And you see this one here. If this one were to fail, bang, the cup catches it. Very important to have the orientation proper. So remember, all the weight needs to be into the cup. So if it's on the top side, so we'll call everything from here up the top. You want the top on bottom. See how the cup's on bottom? The tube's on the bottom of this tube. The top portion is on the bottom. The bottom goes on top. So you can see this lower section of this tube is on top of this tube. And the clamp hinge is on top of this tube. So the weight's going to catch in here, in here, in here, and in here. Set these down, real quick, and I'll reinstall these all properly. Platform, tube, it's our needle. Okay, so we want the weight in the cup. We have the cup on bottom. Obviously, in the real world, I would torque these down to 45 foot-pounds. Okay, then we will top is incorrect. bottom. Cup is on the outside because it's going to want to push this way. Bottom of the raker tube is going to be on top of the tube, and the cup is going to be on top of the tube. See that? Tube on top of tube, hinge on top of tube. Top on bottom on top, top on bottom. Cup bearing the weight that's being forced down here. Cup bearing the weight that's being forced down here. Cup bearing the weight that's being forced down here. And then if this one were to fail, the cup's carrying the weight because this would fall out this way at that point. So, why is clamp orientation so important? If the weight, if something fails on the clamp, whether it be the bolt, which is typically what it is, the cup is going to carry that weight. It's going to catch the weight. So what are some factors that might cause the bolt to fail? Yeah. Over tightening it, which is, it's supposed to be at how many foot-pounds? That's right, 40 to 45. So if it's over torqued, it's stretched, potentially cause it to fail. Anything else? Yeah, backing it all the way up. It's got those hashes in there to keep it from coming all the way off. They back it all the way up. Then they go to tighten it down, and it causes it to cross thread, which damages the bolt and could potentially cause it to fail. So, in relation to the clamp and the weight, where should the load be placed in the clamp? Well, first of all, what are the parts of the clamp? Right, which sides do you got? Well, you got the left and the right, and you got the bolt and the hinge. So it's extremely important to have the weight where? Hinge, yeah. In the hinge side, cup will catch it. Very good. So now I'll take this apart and give each of you a chance to come up here and practice, and then whenever you're ready, let me know, and I'll let you run through. So the important ones are here, 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 and here. You need to be able to install all four of them with 100% accuracy within 5 minutes. That's plenty of time, plenty of time. Everybody okay with that? All right, let's go. This video will self-destruct in 5,